Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Now here on this portion of the Vero board, we will develop the circuit of zero crossing. And here we can check the AC input to our circuit. The frequency is 50 Hz and the RMS voltages are 12.8. So we'll convert these AC voltages of 50 Hz to a square wave of 50 Hz whose amplitude will be 5 volt. We'll use a circuit to convert these AC voltages into a square wave of 5 volt to make it compatible with the input of microcontroller. Here we can find the zero crossing circuit. We are using an operation amplifier, that is LM358, to convert the AC voltages into a square wave of 50 Hz. We are using an operation amplifier LM358 as comparator. LM358 is a dual operation amplifier and we are using only one portion of this amplifier, and we have connected the unused input of this operation amplifier with ground. Here we will apply the AC from the transformer to the non-inverting input of the operation amplifier, and here we have connected the inverting input of the operation amplifier with the ground. It means that we will compare the AC input with the ground. If the voltage of AC1 input will be greater than ground, then the output of the comparator will go to the positive supply, and if these voltages will be negative, it means that these voltages will be less than the ground, then the output of this comparator will go to the negative supply. Here we have used two anti-parallel diodes to protect the input of this operation amplifier, and here we have used another diode to protect the base of this transistor from negative voltages. Now we'll develop the circuit on our Vero board. First we'll solder the 8-pin base in Vero board for LM358 operation amplifier, and here we'll place the operation amplifier LM358 in Vero board. Here we have inserted the 8-pin base in Vero board. First we'll apply plus 12 volt and minus 12 volt to the operation amplifier. Pin number 8 of this operation amplifier will be connected to plus 12 volt and pin number 4 will be connected to minus 12 volt. And here we have plus 12 volt power supply. Here we have connected plus 12 volt to the pin number 8 of this operation amplifier. Now we'll connect pin number 4 with minus 12 volt power supply, and here we have minus 12 volt power supply. Here we have connected minus 12 volt to the pin number 4 of this operation amplifier. Now I'll perform a continuity test of the power supply with this operation amplifier, and we'll also perform a short circuit test of the power supply with ground. Here we have minus 12 volt on the right pin of LM7912. Now we'll check the continuity of minus 12 volt with pin number 4. Okay, minus 12 volts are connected with pin number 4 of LM358. And now we'll perform a short circuit test between ground and minus 12 volt. Okay, there is no short circuit between minus 12 volt and ground. Now we'll check the continuity of pin number 8 of LM358 with plus 12 volt. Here we have plus 12 volt on pin number 10 of ULN2803. Okay, plus 12 volts are connected with pin number 8 of LM358. Now we'll develop rest of the circuit. Now we'll connect two decoupling capacitors with operation amplifier power supply. Here we can see we have connected 0.1 microfarad 50 volt capacitor between plus 12 volt and ground. And here we can find 0.1 microfarad 50 volt decoupling capacitor between minus 12 volt and ground. First we'll connect these two capacitors. And here we have 0.1 microfarad 50 volt capacitors. Now we'll connect the second end of the capacitor with ground, and here we have the ground connection. Here we have soldered the first decoupling capacitor in our circuit. Now we'll connect the second decoupling capacitor with pin number 4 and ground. Here we have inserted the second decoupling capacitor in our circuit. Here we have connected the second decoupling capacitor with minus 12 volt power supply and the ground. Here we can see pin number 5 and 6 of LM358 are connected with ground. And here we have connected pin number 5 and 6 of this operation amplifier with ground. Now we'll solder other components in our circuit. Now we'll connect pin number 2 of the operation amplifier with ground using 10K. Here we have connected a resistor of 10K between ground and pin number 2 of this operational amplifier. Now we'll connect these two diodes with pin number 3 of LM358. Here we have two diodes 1 and 4007. Here we have soldered two anti-parallel diode in our circuit. Now we'll connect pin number 3 of LM358 with the resistor of 10K, that is R8, and we'll connect the second end of the resistor with the AC supply of our circuit. And here we have the one end of the AC power supply. So we'll connect this resistor with this end of the AC power supply. Here we have connected the AC power supply with pin number 3 of LM358 with the help of 10K resistor. We'll also connect a resistor R4, that is 10K resistor, with the ground and AC input power supply. Here we have connected a 10K resistor between AC power supply and the ground. Now we'll complete the output stage of our zero crossing circuit. First we'll connect a 10K resistor with pin number 1 of this LM358. We'll use the fire jumper to connect pin number 1 of LM358 with 10K resistor. Here we have inserted the jumper in Vero board. Here we have connected a 10K resistor with pin number 1 of LM358. Now we'll connect the transistor C8 to 8, the diode 1 and 4148 and 4.7K resistor in our circuit. Here we have C8 to 8 transistor. The right pin is base, middle pin is collector, and the left pin is emitter. Here we have inserted C8 to 8 transistor in our Vero board. Here we have soldered the transistor in Vero board. Now we'll connect diode D10, 1 and 4148 from the base of the transistor with ground. Here we have diode 1 and 4148. We'll connect the cathode of the diode with base of the transistor and anode with ground. Here we have connected 1 and 4148 diode in our circuit. Now we'll connect the collector of the transistor with the zero crossing input of this microcontroller. And here we can check the zero crossing input is coming at pin number 8 of the microcontroller, that is RE0. We'll use this wire bridge to connect the collector of the transistor with pin number 8 of this microcontroller. Here we have inserted the wire bridge in our Vero board. Here we can check pin number 11 of this microcontroller is connected with 5 volt. So I'll connect a resistor of 4.7K between pin number 8 and pin number 11 to pull up the collector of the transistor. Here we can see we are using a 4.7K resistor, that is R7, to pull up the collector of the transistor. First, we'll connect the collector of the transistor with pin number 8 of this microcontroller using this wrapping wire. Here we have connected the collector of the transistor with pin number 8 of this microcontroller. Now we'll connect a 4.7K resistor to pull up the collector of the transistor in our circuit. We'll connect the 4.7K resistor between pin number 8 and pin number 11 of this microcontroller, and we'll place this 4.7K resistor under this microcontroller. So first we'll remove this microcontroller from the base. Here we have placed this resistor in our circuit. Here we have connected the 1K resistor with pin number 8 of this microcontroller, and pin number 8 of this microcontroller is connected with the collector of the transistor. Here we have completed the zero crossing circuit. Now we'll perform a continuity test. First we'll test the connection of this resistor with pin number 8. Resistor is connected with pin number 8, and the second end of this resistor is connected with 5 volt. Okay, the second end of the resistor is connected with pin number 11. Now we'll check pin number 8 of the microcontroller is connected with the collector of the transistor. Okay, collector of transistor is connected with pin number 8 of the microcontroller. Now we'll check the connection of the base of the transistor with pin number 1 of the operational amplifier. Okay, the base circuit is connected. Now we'll perform a continuity test to the AC input of our zero crossing circuit. Okay, AC input is connected with the zero crossing circuit. Now we'll check the continuity test of the emitter of the transistor with ground. Okay, emitter of the transistor is connected with ground. We have completed the zero crossing circuit. Now we'll insert LM358 in the base and we'll check the waveform of our circuit. Here we have inserted LM358 in the base. Now again we'll perform a short circuit test of our zero crossing circuit. Pin number 4 of LM358 is connected with minus 12 volt. Okay, minus 12 volts are connected with pin number 4 of LM358. Plus 12 volts are connected with pin number 8 of LM358. Okay, plus 12 volts are connected with pin number 8 of LM358. Now I'll perform a short circuit test for plus and minus 12 volt power supplies. Here we have the ground connection. Now I'll perform a short circuit test between plus 12 volt and ground. Okay, there is no short circuit. Now we'll check minus 12 volt. Okay, there is no short circuit. Now we'll power off the circuit and we'll observe the waveform of our circuit. Now we'll observe the waveform on pin number 8 of this microcontroller. Here we can check a square wave of 50 Hz. Now we'll use this wave shape in our program to check the zero crossing of the sine wave. Now we'll insert the microcontroller in the base and we'll write a program for firing angle control.